Hey guys, it's been a while since I uploaded my last video on level creation using Unity engine. This time I thought of starting something new to do something different rather than keeping on improving my existing interior level. I got to play a cool game named Ghost of Tsushima. I think many of you are familiar with that title. In this game you do not have any heads up display showing any objective markers for you to follow in the world. The only thing that guides the player to the objectives is the wind in the environment. When you press a button, the wind actually directs towards the objective and the player can look how the environment changes and walk or move towards the objective. I thought of recreating the wind guidance mechanic using the Unity engine in this set of videos. Let's see how to make something like this in our Unity engine. So I'm creating a new scene and let's name it wind navigation. Okay, let's open it, and I am creating a plane to represent the floor or the ground in my level, and I am importing my first person controller that we created in the previous videos. And let's reset our transforms. Okay, now we have our first person controller on this plane. Let's delete our main camera because our first person controller already has one, and in our play mode we can walk around on this plane. Okay, now we have a level with a ground and a walking controller. Let's scale up our flow for about 10 units along x and z axis. Okay, now we need some assets to put on our level as trees. So let's go to the asset store, and I am searching for trees, and we have this realistic tree 9 by Rakshi games. I'll attach the link in my video description. Check that out as well. You can download and import our asset, this tree asset, into our project. I already have imported it, so this is not going to do much change here, and you will have this folder including all the tree assets in your project folder. And I'm going to drag and drop these prefabs into my level. Okay, we have now a small level with a set of trees and a first person character that can walk on this level. Now let's add another object to represent our objective, or the map marker that actually points into somewhere on this map. I am creating a cylinder and I am adding an emissive material so that we can see this clearly while playing this prototype level. I named it as location, and in our material properties, let's tick on this emission and set some color. Now I can drag and drop this material into our cylinder, and we have this glowing cylinder at the center of our map. In play mode, you can see this glowing cylinder at the center. Okay. Now I am going to create a script to handle our wind control logic for this wind guiding mechanic. Let's create a C# script and give it a name, wind navigation behavior, and let's open it in our Visual Studio editor. So we have our C# script ready for editing, but before we start coding, let's create another object in our Unity scene which is actually holding this script during this gameplay. I'm going to create a wind zone by going to 3D object and wind zone. Wind zones give a force of wind to your game environment. So if you go to play mode, you will notice that all of our trees are slowly swaying like they are affected by a wind force. This movement is created by our wind zone. We can change the turbulence or the main field and pulse magnitude and pulse frequency to create different behaviors of this wind zone. You can see there's a transform component attached to our wind zone game object, which means you can rotate this game object around an axis that we want and change the direction of this wind zone. Also, you can see that this wind zone component has a mode which is set to directional. This directional mode lets you have a wind zone that blows wind to a given direction. Okay, we have a source of wind, and now we can access this wind source or the wind zone in our code. Let's create a public field of wind zone type to keep a reference of the wind zone in the Unity scene in our C# script. And also let's make some additional fields like our map objective. Let's call it objective. This map marker will be placed using this objective transform. Then let's make another state. Boolean variable is guiding. This will actually check whether the game's ready to guide you through the wind or not. So what should happen in the update loop is, if is guiding is true, then the guiding wind should blow across the environment. Okay. Now we must make a logic to read the user's input in our game loop. We'll condition using input dot get key and pass a key code for the letter Z in our keyboard, which is keycode dot Z. Here we will actually trigger the guiding wind to start blowing in our game scene. I'll create a new method of void type to start guiding wind whenever this Z key is pressed within the game loop. And here I should call this start guiding wind whenever the Z key is pressed. Right. Guiding wind. Okay. Basically what our start guiding wind function or method should do is, if the is guiding boolean is true, it shouldn't do anything. If not, we have to start enabling the guiding wind after that. Now we have a field to uh, access the wind zone and to access our objective in the map, and also we'll need the field to uh, access the player's position so that we can calculate the direction from the player's position to the objective's position and assign it to our wind zone. So I am creating this player transform. In our start guiding wind, we must calculate a direction vector from our player to the objective. Let's create a vector 3 called direction and assign a vector of zeros. This direction vector will be calculated by taking the vector of position of the objective's transform relative to the player's position vector. This relative position vector is calculated by subtracting the player's position from the objective's position. This equation is made up using the theory of relative motion. If we consider the game world as the reference frame or the earth, and this objective and player are 2 points, let's call them O and P respectively. This direction vector, what we want from this direction vector is the displacement. Let's call it S. The direction vector S O comma P. To calculate this S O comma P vector, we have to add S O comma E with S E comma P. We have positive S E comma P in our equation. we can convert this into negative sp comma e. Here this e means our Unity game world. So now in this equation, in our right side, we have two fields that actually have so comma e and sp comma e. So by subtracting so comma e and sp comma e, we can calculate this direction vector easily. Now to see our equation in action, we can actually uh, try this quickly by drawing a debug ray in our Unity scene. We can call it by debug.drawRay and pass our starting point, which is actually the player's position, which is player.position, and the direction is the direction vector that we just calculated. Alright. Now in the Unity scene, let's select our WinZone object and attach our wind navigation behavior into this game object. Then we can give references to our WinZone, the player object, and the objective game object into this script component. I'm going to rename my cylinder as objective, and let's go back to our WinZone. Right. I'm going to drag and drop this into our objective, and then for the player, I'm dragging in my player game object. Now if we go and check our play mode, first let's zoom in to get a better view out of these trees. You can see our first person controller moving around, and if I press the Z key, you can see a white line is joining our player object and the yellow colored objective. This line is drawn by using the direction vector that we just calculated in our start guiding wind method. So it proves that the outcome of our calculation gives the correct direction from our player to the objective transform. Now if we can rotate our wind zone to align with this direction vector, then the wind should blow in the direction pointing from the player towards the objective. That is what we should do at the end of this start guiding wind method. For that, let's first access our wind zone from our wind zone variable. Then we can access its rotation. No, we have to access its transform and then access its rotation and assign a certain value from this direction vector. Unity's quaternion class includes a convenient method that can actually rotate a transform or the rotate the transform's forward vector towards a given direction, which is quaternion dot look rotation. We can pass the direction vector into this look rotation method, and this method returns a rotation value that aligns our wind zone's transform along this direction vector. Let's test our code in the play mode. First, let's increase our main value of the wind zone so that the change is noticeable. Okay, my players here and the objectives here. Let's increase our main wind a little bit. So if I go far from this objective, let's zoom out and see whether the wind direction changes. Okay, when I press the Z key, you can see how the wind direction switched to a different direction, because the wind game object, our wind zone game object, rotated towards the direction that we calculated. Okay, this concludes our attempt to change the direction of the wind towards the objective. In the next video, we will try to make this wind transition more believable than just snapping from one direction to another. Thank you guys so much for watching, and see you again in the next video.